Good evening, everyone. Today we're gonna start. Today we're gonna continue our journey into the world of Kubernetes, and today I will show you how we can deploy our workloads to Kubernetes. How can we automate the deployment of our workloads, of our Kubernetes workloads using, guess what, Terraform. Before we move forward, I want to demonstrate the even easier way of deploying Kubernetes workloads deploying Kubernetes clusters using Terraform. You can just go uh, this Google search, Terraform build EKS, and there is an awesome piece of documentation that explains how to quickly create Kubernetes clusters using publicly available modules that we're already familiar with. It will create these VPCs, some clusters, and so on. What we need to do, that's the fastest way to create your Kubernetes cluster. So what should we do? On the repository, yeah, very good. Thank you very much for bringing this up. I forgot to share. Yes, let me show it once again. So that's the Google search that we need to do, Terraform build EKS, and that's the documentation. It is using Terraform modules, same modules that we've used before, to provision fully working EKS cluster. So as any other resource, we don't have to write anything from zero. We just reuse open source modules. And here is what it will deploy, put out a scaling group, EKS cluster, and so on. Let me clone this then one more time. And we'll need to open this and edit some files to make some slight readjustments. So these instructions clearly explain it requires us to comment out some certain parts of infrastructure, in particular cloud block of it. This doesn't have one. Probably it's a little out of date. The documentation probably out of date. Let's then do one more thing. So by default, it demonstrates two auto-scaling groups. We don't need them. We will move forward only with one. What it is doing, it is calling EKS Terraform module. It is deploying it into a VPC. This one has separate file, very similar to what we did previously. Also deployed from the module. Yeah, let's make sure that these are good. These are also good. Yeah. Let's run Terraform apply. Terraform TF line 6. Yeah, that's the one. Sorry, just a second, I'm confused a little. Perhaps we can do it even radically like this. No. Sorry for that, looks like they've changed something since I checked this last time. Give me just a couple seconds, I'll find out what's wrong. Probably that's because maybe yeah, I understand what was wrong, and that's totally my fault. I picked I cloned it previously and picked wrong directory. That's the case. I was editing wrong file. This one has the word cloud in it, one that we need to comment out. Sorry. Yeah, let's repeat EKS. We don't need second node group. We also we don't really need these EKS add-ons for now. Let's also delete this for now once more. Let's have max size, min size 3. The rest is fine. Oh yeah, to iterate what we've done. We've cloned this repository. We've opened the code from it in Terraform.tf. We have commented out this, and you will find these instructions in this documentation over here. And I've also removed some redundant and needed things like separate auto scaling group, and there was also some EBS driver configuration that we also don't need right now. Let's run Terraform init and Terraform apply. So it will take at least maybe 7 to 10 minutes to create this cluster. While we're waiting, I see a hand raised. Ahmed. Okay, then when you think you're ready to ask, feel free to just raise a hand again, and we'll have a chance to discuss your question if it's still relevant. Maybe someone else have something to add or any questions? Okay, then let's just wait until it created. And I'll show what we do next. Yes, Ritika.
So Vladimir, did you make another folder or a directory? Because earlier we were working on Terraform in 21 days.
Yeah. So I've cloned it myself. Yes, that's right. And probably that might be a good idea to port these changes back to Terraform in 21 days once we finish. Yes.
Sure. Thank you.
So in the meantime, let's prepare some structure. Let's make some additional preparations. You remember the 248 game that we had installed previously? So we will run it in Kubernetes, and for that there will be the Dockerized version of this application. There is a container already, which is doing exactly this, which is running this 248 web game. I will first pull it. After that, I will run it as a Docker container locally, and then we'll create some deployments and automate them on Kubernetes. First, I pulled this container using the docker pull command. Then we can run it. We need to forward port 80 into our outside port 8080, and also it should run in so-called detach mode and interact mode. And probably, reorder the ports -p80/e80. Okay, cool. Now we can open localhost on port 8080 and we'll see our web-based game. No? Okay, let's try a different one. This time it works. We had to do different sequence. Inside container there is port 80. I always confuse this. So inside container there is port 80 and Nginx running on port 80, but we are not able to run on port 80 ourselves because it's a privileged port. So we'd rather pick 8080, and I always mix up what should go first. Yeah, we have this 48 running from within our container. And our goal is, as soon as our Kubernetes cluster is available, run this application on Kubernetes, expose it to the outside world, and most importantly, today we will also automate the deployment of Kubernetes workload itself, again, as usual, using Terraform. Any questions so far? All right, very cool. We have a cluster. This time it is running in US East 2 region. Let's run. Let's create a kubeconfig for it. This time we copy the cluster name. Let's get our nodes. Very cool. So, and we can immediately run our deployment. We'll call it 248-game. And image will be the one that we've run through our local Docker command. Okay, for some reason it's unable to find this image. Let's have a look what's wrong. We can run kubectl describe pod and the pod name. Sufficient scope. That's strange because this is a public image, and we should not require any authorization. But we can always work around it. Okay, yeah, I've noticed that. Thank you very much. This is extremely valuable. I've made another silly mistake and provided wrong image. Oh, yeah, this time it is running. So let's, as usual, scale it, mean create more replicas. And we will expose it. I am recreating this deployment because I forgot that Kubernetes doesn't allow service names started with numbers. It should be DNS compatible, which means it can include numbers, but should start from Latin letters. Let's check our service. It already has load balancer assigned. Let's open our load balancer. Let's check our load balancer, why it is not working. 1 second. Maybe some DNS issues. The region is US East 2 this time. Yeah, load balancer is there. Let's try one more time. Good. We just needed to wait a little. So good, cool. We did very similar to what we did yesterday with our Nginx, but now the question is, how do we automate this? Should we always type these commands again and again? And the answer is no. We can create these objects through YAML and basically automate them afterwards. What we can do is, for example, see what current YAML has our current deployment. We can do this by running kubectl get deploy in 248 minus o YAML. And there we have it. And we can redirect it to a file, for example, deployment.yaml. Let's do the same for our service. kubectl get svc game 248 minus o YAML service.yaml. Here we have these two files. So what we have generated is what we have generated contains a lot of unneeded information, unneeded files. So let's clean it up a little. I'll simply delete everything that's not required. And the same for service. It is a lot of metadata fields, almost everything except for the labels field, entire metadata managed field section, and the entire status field. We might also want to remove cluster IP, so it just don't have. So it just will not conflict in case we want to reapply. So now what can we do? We can run kubectl. No, let's delete it manually first. kubectl delete deploy game 248. kubectl delete service 248. And what we can do is we can use this YAML file that we created, run it via kubectl apply -f deployment YAML. Now we have our deployment back, just as we described, having all the settings. When I refresh this, it's no longer available because we deleted our service, but we can recreate it using kubectl apply. And seems like I deleted something that I shouldn't have deleted. Yeah, that's name. We run kubectl swc. There will be there will be new load balancer that we as well can test from our browser. Okay, it might take some time for it to start resolving, but that's not the biggest deal. Overall idea is clear. Now the question is how we automate it further. Yeah, because we still have perhaps too many commands. We have to run kubectl apply twice. What we can do is we can think of these YAML files as, for example, binary, not binary, I would say source code for some program. Yeah, and we can create similar to how source code is compiled into packages. We can compile our YAML files into something called Helm chart. And Helm is a next thing that we'll learn is a package manager for Kubernetes. It combines all our YAML files into a single one, and we will use Terraform to apply this package to our Kubernetes cluster automatically so that we don't even have to run any kubectl commands. Yes, Helm package manager, that's right. We'll create a folder. Actually, we'll create several folders. First one will be Helm. That will store all our Helm charts. Inside there will be game 248. And inside there will be some files. There will be directory for storing our Helm template, our templates themselves. We can move it to here. This one also go here. We can have the chart.yaml that has some required information. So it will have API version, which can be v2. It will have name equals game 248. It will have version 0.0.1. And probably that's it. Oh, now what we can do? Let's delete everything again. And I will show you how to install it using Helm. And probably we need also to remove this thing. Yes, very cool. So what we can do is now do Helm ls. It will give us this installed package, this installed chart. And when run kubectl get svc, we'll get service that corresponds to this chart and is managed by this chart. And also have deployment. Yeah. So it is like it's like an onion, right? It's not just a single automation piece, it's multiple layers of automation. And what I will do this is I'll connect everything together into a into a single package, and we will use Terraform to install this Helm chart, which will install our Kubernetes manifests. First, let me uninstall everything, and we can move forward. And give me just a second to check my notes. I'll have it as a separate file. We need to declare a separate provider. So Terraform has provider infrastructure, provider architecture that allows to connect to multiple clouds, and also it allows to connect to things that are running inside your Kubernetes cluster, for example, that you deploy. Let me copy something from our provider config. 1 second. There is no provider Kubernetes. Okay, not a big deal. We'll then write it from scratch. we need a couple more data sources that will instruct authentication information. So basically, what we're gonna do is kind of generate same secrets and same credentials that otherwise should have written in our kube config. And what we'll do is create another, this time Terraform resource. Let's call it Helm release. And it's basically an equivalent of what we have deployed previously using the Helm install command. And this time we'll run Terraform apply. Yeah, and our cluster names do not match. Let me fix that. Module EKS. Okay, probably that's the output. Here we have this argument name. Why is that? Interesting again. It's always throwing weird stuff. Let's try again. Maybe I forgot to save some file or something. Yeah, Helm TF line 6. Okay, let's double check once again. Yes, okay. Data, name argument. Okay, that's my fault. I checked the cluster ID output. It says the ID of the cluster only is returned if EKS cluster created on AWS outposts. So it's simply like empty ID. Instead, perhaps, yeah, we could have used cluster name. How I troubleshoot this, right? I went to the module code, which is in the Terraform folder. I suspected there is something wrong with outputs and first checked the output, and even like description of this gave me the hint. I checked which one can be useful, which other one can be useful, and switched to it. And it says, yeah, very cool. It will now create this Helm release for us. Fingers crossed. Cool. And when we run Helm ls, we'll have this Helm chart now deployed through through Terraform. So what it gives us? It gives us an ability to make Terraform a universal glue that connects everything all together, and we don't have to write any third-party automation or integrations. And as long as there is a provider, it can be Kubernetes, it could be Helm, it could be anything else. We can put this Terraform on everything. We can make our entire infrastructures end-to-end deployable through Terraform. And this will significantly simplify our lives and make us more happy. So what we'll do is update the repository, commit files, and we're done. Any questions? Okay. Yes, Sanjeev.
Hey, Vladimir. So if there's a new code change to the, so what type of changes can we expect in the